Welcome to today's webinar on cover crops and weed management. I am Erin Haramoto. I'm at the University of Kentucky, where I do research on cover crops and how they contribute to weed suppression. So a short outline for today's webinar. We're going to discuss first some of the goals of using cover crops for weed management. I'm going to do a very brief introduction to both cover crops and weeds to make sure we're all on the same page. And then we'll move into discussing how it is that cover crops suppress weeds while those cover crops are growing. And we'll think about some scenarios and situations in which we care about this suppression. And then we'll do the same for how cover crops suppress weeds after they've been terminated. So a few things to keep in mind as we're going through this webinar today. First off, cover crops rarely, if ever, are going to provide adequate weed management on their own. And by adequate, I mean a level at which they're not going to be causing considerable yield loss. So we need to be using other tactics to bring weeds down below those levels. We can be combining our cover crops with other tactics, so including herbicides and cultivation and different cultural practices as well. And so really we can think about cover crops as helping to improve the efficacy of these other management tactics, and also contributing to preventing weed problems in the first place. So preventative weed management rather than reacting to them and trying to kill them once they're already in the fields. So to this point about combining multiple tactics into a program of integrated weed management, a lot of our weed management tactics that we use today, like herbicides and cultivation, are what we call big hammers. They're very effective and they kill most of the individuals to which they're applied. So there's a huge advantage to individuals that can survive those tactics. So for example, herbicide resistance, if you are the one weed that can survive an herbicide application, there's less competition for you, and it's much more likely that you're able to pass those traits on to your progeny. So also, weeds are able to adapt to any one tactic if it's used exclusively. This is one of the things that makes weeds so problematic. So if we use the same herbicide over and over exclusively and at the same time in our growing season, weeds are going to adapt to that by evolving resistance. So also the types of weeds that are present, that is our weed community, can shift to more problematic species that aren't well controlled by any given tactic if we're only using that one tactic. So again, we want to be thinking about cover crops as part of integrated weed management systems. We want to be stressing weeds at multiple stages in their life cycles and in multiple ways to reduce the potential for these negative consequences. So all that being said, what might our goals be for using cover crops to manage weeds? So the first one is to reduce the weed density. So we have fewer weeds that we need to kill, and that also means a lower chance of evolving resistance or having weeds adapt. So this is just a numbers game. If one individual in a million or 10 million just is going to have a chance mutation that confers resistance to an herbicide, if we have fewer weeds out in our field, there's a lower chance of that happening. So our second goal would be to slow weed emergence. So this gives us longer windows available for practices that might be more effective against smaller weeds. So think about post-emergence herbicides that are applied when weeds are supposed to be 4 to 6 inches tall, or cultivation that's more effective on seedlings. It also allows our crops to gain a competitive advantage against any weeds that are in the field. So our third goal is going to be to decrease weed growth. So this makes the weeds less competitive against crops and also capable of producing fewer seeds. And so that leads to the fourth goal, which is to have fewer weed seeds produced, both in and on the soil, remembering that each one of those seeds is a potential future weed. And lastly, cover crops can also contribute to rotational diversity, and this can have a huge benefit in suppressing weeds at multiple stages in their life cycle in multiple ways. But it's a little bit more of a complex topic, and we're going to focus on the first 4 of these today. So now that we've gone through that, let's do a very basic introduction to cover crops. What are these cover crops? And so our USDA definition is that they are plants that are grown, but they are not harvested. So they're grown specifically for the benefits that they are providing to our agro ecosystems. And those benefits can be related to the soil, so reducing soil erosion and improving soil health, also be weed suppression, among many other potential benefits. So the specific management of these cover crop, the rules might vary depending on crop insurance policy provisions and also any cost share funds that are received. So producers really need to pay careful attention to what some of those rules might be, because they might influence the management and the weed suppression that might result. So when do we grow these cover crops? We typically think about them as growing outside of our cash crop windows, again, with the goal of using resources that would otherwise be lost, or in our case, used by weeds. So a traditional model is that we grow these in the field at different times when our cash crops are not in the field. So if we're talking about summer cash crops like corn and soybean, those empty windows are in the late fall after harvest through to the early the following spring before we plant our next rotational crop. So in those cases, we might plant something like a wheat cover crop over the winter. It's then terminated and all of that material stays in the field, and we plant our next cash crop into that residue. And in this case, you can see corn in that residue. So just quickly to point out, there are other types of windows. We might have cover crops in the field at the same time as our cash crops, but just in different spaces. So you can think about these being between rows or beds of our cash crop, like an interseeded annual ryegrass cover crop between corn rows, or a living mulch. This photo on the bottom is a low-growing summer annual grass called teff that is used between the raised vegetable beds at one of our organic research farms at the University of Kentucky. And you can imagine how this is helping to suppress weeds between those beds. It's improving field workability. It improves access if it's wet. You don't get as muddy if you're in there. Pulling weeds out of the plastic, the holes in the plastic, or harvesting the crop. Okay, so let's move on and just briefly touch on the life cycle of our annual weeds. Don't forget we have biennial and perennial weeds as well, but we're going to focus on annuals for this webinar today. So our life cycle starts with seeds in the soil that germinate and emerge to form seedlings. These seedlings then use resources and grow until it's time for them to reproduce and produce seeds that are shed back into the soil. And this process starts over again from seeds in that soil seed bank. So how can we impact this process using cover crops? It turns out we can have a pretty large influence on a lot of these processes. So starting with this germination and emergence, through changes to the soil environment, we can be reducing the number of seeds that germinate, delaying any germination and emergence to give crops a competitive advantage, so leading to fewer weeds and delayed emergence. We can be changing resource availability in our fields through these cover crops, using resources from weeds to keep them smaller so they're not able to grow as much. And then lastly, we can be affecting reproduction and the production of seeds and further inputs into the seed bank. So just to point out, there are all sorts of things happening in the soil, and cover crops are going to be impacting a lot of these through their changes to the soil environment, including seed predation, seed decay, changes to the moisture and temperature in the soil that can influence whether or not seeds are going to survive over seasons or how long they're going to survive for. But again, we're going to focus mostly on the above ground parts of this today, but do know that there's a lot of other things happening in the soil. So to get into the meat of today's presentation, let's switch gears and talk about how cover crops can suppress weeds while those cover crops are growing. And again, think about situations when we care about this. So here's a diagram of a growing cover crop. It looks like a small grain. You see a few weeds trying to grow within that cover crop and some seeds in the soil here. And so how is it that these cover crops are suppressing weeds? Well, it's through changes to the soil environment that are going to impact weed seed germination, seedling emergence, and the growth of these weeds. So for one, the cover crop is intercepting light, and we have less light reaching the soil surface. And a lot of seeds need that light as a cue to be able to germinate. And those small seedlings also need light to start photosynthesizing. In part because of the blocking light penetration, cover crops are going to be reducing soil temperature, which can reduce the number of seeds that are going to germinate and also reduce their rate, so slow them down and delay the emergence. We can have variable moisture effects. So on the one hand, these cover crops are live and growing plants that are transpiring and pulling moisture from the soil, but they're also lowering evaporation. So the net effect on moisture is going to depend on the amount of precipitation we have, whether or not that cover crop is really actively transpiring and removing moisture from the soil. We can also have variable nitrogen effects depending on what type of cover crop we're growing, whether it's a legume, for example, or a small grain that's going to be removing nitrogen from the soil. And there's the potential for allelopathy depending on what cover crop species we're growing as well. So lots happening, lots of ways that the cover crops can influence the soil environment while they're growing. Again, with the net effect of having fewer weeds around through impacts on germination, delaying the emergence of those and slowing their growth by using resources that those weeds need, and then having fewer seeds produced as well. So what types of weeds are we talking about here? If we're talking about winter cover crops that are planted in the fall and grow over the fall and winter into the spring period, we're talking about our winter annual weeds like henbit and common chickweed and horseweed. These may be problematic depending on crop rotation. So for us, we grow a fair bit of winter wheat in the state, and we might care about some of these winter annual weeds. Additionally, horseweed for us is problematic in multiple cropping systems. It can emerge in the fall. And so using these winter cover crops is a really powerful tool in an integrated weed management system for that particular species. We might also have cool season perennials present that can be suppressed by these cover crops while they're growing. And if we're talking about summer cover crops that are grown in the warmer seasons, we're talking about summer annual weeds and warm season perennials. And you can think about whether there's room for these summer covers in your particular system. One example is just to the north of us and where we are growing winter wheat. It might not have enough growing season left to grow double crop soybeans, so we might use a short season summer cover crop in there to keep the soil in place, be adding organic matter to the soil, and keeping back some of these warm season weeds. So just to show you what this might look like, how well we can be suppressing weeds with these cover crops while they're growing, we're going to take a look at some data from a small grain rate trial that I've done here in Lexington. So these are cereal rye and wheat cover crops planted in mid-October in multiple years, and we sample these in April before we plant our next cash crop. And so this figure is showing us the amount of cover crop biomass here and the amount of winter or weed biomass contained within that cover crop on our y-axis. And so you can see there's a pretty direct negative relationship between these. The more cover crop biomass I have, the less winter weed biomass I have. And in part, the cover crop is using resources that the weeds need to be able to thrive. So important to remember, these are weeds actually growing in that cover crop. We're not talking yet about our next cash crop. And so the cover crop is reducing their seed germination, seedling emergence, and using resources with that from them and outcompeting them so they're smaller. And those are all things that contribute to us having less weed biomass. So if I'm interested in this, if I want this as one of my goals, what's more effective for suppression during this time? So we really want to have cover crops that are going to be effective in covering the ground and in using a lot of resources. So growing quickly and producing a lot of biomass. And just to show you a couple of photos of what this looks like, on the top is cereal rye cover crop grown about 2 months after it has been planted. And on the bottom is crimson clover. And you can visually see which one of these is producing more ground cover, using more resources for these weeds. If you look closely between the crimson clover rows, you can see some weeds emerging there because the crimson clover is not effectively shading the ground and using that light that those weeds need to germinate and emerge. So these small grains, particularly in our cool season windows, some of our brassicas tend to be better at suppressing weeds during this time than legumes. If we're talking warm season, we do have some legumes like cowpea that can be very effective in covering the ground and producing a lot of biomass. Sorghum, Sudan grass, and buckwheat are other examples of warm season cover crops. If they fit within your crop rotation, that can be effective in suppressing weeds while they're growing. And there are others as well for both of these windows. It is important to note too that we need to match the cover crop to the season. So if it was mid-October for me in central Kentucky and I was harvesting corn and I wanted something to keep back my fall emerged mare's tail, for example, I wouldn't plant radishes at that time. Even though they're very effective in covering the ground and they produce a lot of biomass, it's a little bit too late for them. And so they just wouldn't be as effective. So I would choose a small grain because it fits better within that planting window that I have. So other than the species selection, how can I achieve ground cover and biomass? What else can I do? We're going to take a quick look at how seeding rate can influence ground cover. Again, from that small grain rate trial that I plant in early to mid-October in central Kentucky. And then we measure ground cover starting in mid-November and continuing through the fall and winter period. And this figure is data from that trial where we have two seeding rates, a pretty low seeding rate of these small grains and a higher seeding rate. So almost 3 times as much seed between these two. We're looking again at that percent ground cover in mid-November. And you can see that the higher seeding rate did indeed produce more ground cover, almost twice as much through the fall. And this continues through the winter period as well. So this ground cover is good for suppressing those weeds. It's also great for reducing soil erosion. So what about achieving more biomass? Does seeding rate influence the amount of biomass that's produced? So same trial, that small grain rate trial planted in the fall, and now we're measuring biomass the following spring before we're getting ready to kill those small grain cover crops and plant soybeans. So same seeding rates that you see here, but now we're looking at biomass the following spring. And you see there's a much lower difference in biomass between our two seeding rates. So having higher seeding rates generally does not produce more biomass, especially for these small grains. They can tiller, these plants can compensate for these lower seeding rates and still produce pretty similar amounts of biomass. In this case, we have 3 times as much seed in the high seeding rate than in the low seeding rate. We don't have anywhere near 3 times as much biomass. We don't even have twice as much biomass. And we've seen this effect pretty consistently in multiple regions for multiple types of cover crops too. So seeding rate can influence ground cover, but it has a much lower influence on biomass produced. And so if you really want to maximize the biomass and resource use by these cover crops, we want to be choosing the right species. So one of these high biomass species planted at the right time and using the right method. And one last point to make about this suppression while the cover crop is growing is that the results are really going to vary depending on the weather, specifically the planting and growth conditions as well. And because this can all impact the resource use by the cover crop and what's left over for the weeds. So for our cool season plantings, if we plant something too late, or we have a really cold winter or dry weather, we're likely going to have less cover crop biomass. And we see this in another data from another trial that we've done with hairy vetch. I'm going to show you 2 years of data, hairy vetch biomass in the spring when we would terminate it prior to planting corn. And you see that in the second year we did this trial, we had just over half as much biomass as we did in the first year. So this was a combination of a very cold winter that really reduced the growth potential and a cold fall that reduced the growth potential for that hairy vetch. And then you see how different these 2 years are in weed suppression. So the second year where we had less hairy vetch biomass, we had more weed biomass than we did in the first year. So looking at all of how these factors influence cover crop biomass are going to also influence how well they're suppressing weeds. So to sum up this part, yes, it is true that cover crops can suppress weeds while those cover crops are growing. And they do that by changing the soil environment and using resources, with the net effect that we have fewer weeds, smaller weeds, and fewer weed seeds entering our soil seed banks. So the amount of suppression that we get is going to be affected by the species we choose, the ground cover and biomass that's produced, and the weather and the planting date. And so if you are really interested in optimizing weed suppression during that cover crop growth phase, again, remembering that we're talking about weeds that are growing with the cover crop, so you have to think about whether this is a cohort of weeds that you want to be suppressing. We can choose species that produce more ground cover and biomass, like those small grains and brassicas for our cool season window, and maybe like cowpeas or sorghum Sudan grass or buckwheat for our summer or warm season window. We might also consider increasing the seeding rate to increase the amount of ground cover that we get. And then to optimize this overall, we want to be planting the right species at the right time and getting a good stand with even coverage. And these are topics for a whole new webinar. But for today, let's move on and think about how it is that cover crops suppress weeds after they've been terminated. And again, what situations we care about that. So we had our model here of the cover crop growing and all of its impacts on the soil environment. Now we've killed this cover crop. And if we're in a no-till system, we have a mulch layer sitting on top of the soil surface from that cover crop residue. And that mulch, just like a straw mulch in your garden, is going to have large influences on the soil below. So it's blocking light to the soil surface. So again, any weed seeds that need light to germinate aren't getting the proper cues. They're not able to photosynthesize until they reach through that mulch layer. It's holding in soil moisture by reducing evaporation. It's decreasing soil temperature. We can have variable impacts on nitrogen, again, depending on what kind of thing we planted. So you start to see how these mulches are changing resource availability in the soil and how many of those resources are left for these weeds. So really importantly, these mulch layers also form a physical barrier on top of the soil surface. And that's really important for suppressing the emergence of these small seeded broadleaf weeds, like this common lamb's quarter seedling you see here on the bottom left. So this weed seedling is really tiny. Across the cotyledons here, it's maybe half an inch across here. So you can picture how thin and spindly this stem is going to be. So these small seeds also don't have very large amount of reserves contained within the seed. So after they germinate, they really need to emerge from beyond the soil surface or these mulch layers and start photosynthesizing really soon, or they're going to die. So these combinations are really effective, as we'll see, in suppressing these small seeded annual broadleaf weeds. So just to point out, in tilled systems, we can be incorporating these cover crop residues. And we really have the impacts are a little bit harder to predict. And the effects on weeds are not quite as strong as they are if we have mulch layers on the soil surface. And that's what we're going to focus on for the rest of today. So to give you a picture of what these might look like, the top left here is a cereal rye cover crop, and we actually planted corn directly into this before killing it, so like in a planting green method. The picture on the bottom, this is cereal rye that was terminated with an herbicide, and again, we'll be planting into that. And so we have these intact residue mulch layers through which our weeds have to emerge. And here's a photo of crop emergence occurring through that residue. So what types of weeds are we talking about here? If we're using a winter cover crop that we're terminating in the spring, we might be planting soybeans into that residue. We're talking about weeds that are going to be emerging in that spring-summer period and be problematic in our next cash crop. So these can include our summer annual weeds like our amaranths, common lamb's quarters, our summer annual grasses like foxtails and crabgrass, warm season perennials too, and we'll talk about the degree of suppression of these different types of weeds. If we're talking about a summer cover crop, whether it's terminated in summer or fall period, again, we're talking about weeds emerging after it's been terminated. So if we're terminating later in the fall, we might be thinking about our winter annual weeds like henbit and common chickweed and that horseweed as well. So what influences how well these mulches are going to be will be suppressing weeds? So the first thing is the amount. How thick is that mulch layer? How much biomass did that cover crop produce? So the more biomass that was produced by the cover crop, the more mulch we have, the thicker that mulch layer will be, and the more weeds will be suppressed. So termination method also influences how suppressive those mulches will be. If the mulch is more intact and evenly distributed, it will be more suppressive. So roller crimpers are nice for creating a evenly distributed and intact mulch layer. And they can be used in concert with herbicides to ensure cover crop termination. Both of those are better than mowing the residue, which chops it up into smaller pieces. And while it might be evenly distributed, they tend to decompose faster. And tillage and incorporating residue leads to less suppression. So the persistence of that mulch, or how long it lasts, also relates to how long it will be suppressing weeds. So mulch cover crops with high carbon to nitrogen ratios, like from grasses and small grains, tend to persist longer than do mulches from legumes that have more nitrogen relative to carbon, or a low carbon to nitrogen ratio. So if weed suppression in the next cash crop is a goal, then we want to do what we can to have a thick and intact, evenly distributed, and persistent cover crop residue mulch layer. And you can think about this like you're mulching in your garden with straw. Only if you're in a 160-acre soybean field, you can't just go out and add another bale of straw to replenish it. So what types of weeds are going to be reduced by these mulches? Again, our small seeded broadleaf weeds are suppressed by these residues. So first, they need light to be able to germinate. Often, their seeds will have this light requirement for germination as a cue. You can see the photo on the right here. These are two common lamb's quarter seedlings with a very, very, very thin hypocotyl, or that little stem there. So they're not really able to penetrate up through those thicker mulch layers. They also really need to start photosynthesizing right away because their seeds are so small, they don't have a lot of reserves. So large seeded broadleaf species like the morning glories you see in the photo on the right here, they are not suppressed as well by these mulches. So for one, their seeds are less likely to have that light requirement for germination. They also have a stronger hypocotyl or stem, and they're able to penetrate through those residues. And they also have more reserves in their endosperm, so it can take them longer. They can tolerate a delay in emergence. Annual grasses are also generally not suppressed as well by these. They tend to not have a light requirement for germination. And the coleoptile protects that seedling. It almost acts like a spike as it helps to emerge through those mulch layers. And lastly, perennials also not very well controlled, not all of them at least, especially if they're emerging from vegetative structures below ground. Those vegetative structures can serve as an energy reserve to help the seedlings emerge through the mulch layers. So how effective can these residue mulches be in suppressing weeds? We're going to take a look at some data from a trial in Georgia that used legume and cereal rye mixtures. They terminated and they used a roller crimper, again, to lay the mulch down flat and evenly distribute it. And they strip tilled and planted cotton. And the figure that we're going to look at had no additional herbicides applied. So they rated the Palmer amaranth control between the rows of cotton, so where it was not disturbed by the strip tillage, and we have a mulch layer. And they related the amount of cover crop biomass to the degree of control of Palmer amaranth. And so you see the more biomass we have, the better the control of Palmer amaranth was. Now to point out, even when they had a lot of material in there, they're still getting 80–90% control of Palmer amaranth. So this is a good reminder that we can't rely solely on that mulch for weed control. We want to have something else to be killing those remaining weeds. So what about the relationship between weed density and cover crop biomass? Remember before we talked about cover crops reducing the number of weeds emerged. Do their residues also reduce the number of weeds that emerge? This is trial data from one of our own trials. Again, that cereal seeding rate trial that we did, where we killed the cover crops in the spring. We planted soybeans 4 to 5 weeks later. The data we're going to look at is from areas of the plot that did not receive a residual herbicide. And then we counted the weeds prior to applying our post-emergence. And you can see that as you increase the amount of cover crop residue, we had fewer weeds. Again, a pretty direct negative relationship there. Now, so we have fewer weeds out here where we have more residue by the time we're doing our post-emergence, but it's still too many. We still have 20 weeds per square meter, which is more than we want. So we still have to spray, but this is helping us from a resistance management point of view, having fewer weeds that we need to kill with that herbicide. So one last piece of data here is just to show how these cover crop residues can influence the size of weeds and the timing of windows that we might have for our post-emergence applications. This is a data from a trial in Tennessee where they grew legume cover crops before corn, and they timed their post-emergence applications in the corn to weed height, and they were specifically looking at amaranth. They timed it to weed height in plots with the cover crop residue. So when weeds and plots that had the cover crop residue were 6 inches tall, they said, okay, it's time for us to spray our post-emergence treatments. And those were a variety of different treatments with different herbicides. And what they saw is that where weeds in plots without any cover crop residue were taller, on average 3 inches taller than the ones that had the residue, suggesting that there was either a delay in emergence or that the growth of those weeds was slowed. So the upshot from their trial and their major conclusions is that in plots with the cover crop residue, the weeds reached that 6-inch height, again, the target for applying that post-emergence application, 3 to 4 days after those in the untreated plot. So they had a longer window, 3 to 4 days longer, to apply that post-treatment. And this, as we all know, the weather at these times can be challenging. So having that longer window is beneficial. And this also helps us with resistance management too, because we're keeping those weeds smaller and targeting smaller weeds with the herbicides. So we know that soil residual herbicides are really key for helping to manage herbicide resistance. And one of the questions I get is, are they going to bind to residues in no-till systems? And is that going to make them not effective? So these herbicides need to reach down into the soil where they come in contact with germinating weed seeds, and that's how they have their activity. So the amount of binding can really depend on the product that's used and the type of residue and how much residue there is. But in general, if we get an activating rainfall or we can irrigate soon after that application, it can mitigate any potential binding. And also, we get the question of whether or not they're necessary if we have this much residue in the fields. And yes, they can provide really good insurance against areas where the residue might be thin or have gaps. And you see that in this red circle here, where weeds are starting to emerge, where you can see some soil. And they're also effective against species that are not well suppressed by residues, like some of the morning glory species in the upper right of this photo. So to sum up this part, after cover crops are terminated, yes, their residues can suppress weeds, especially in no-till systems. And we get better suppression from having thick residues, mulch layers that are intact and evenly distributed and last for longer. Some of our weeds, including our small seeded annual broadleaf weeds, will be suppressed more than others. And again, it's not likely that these residues are going to provide what we would consider to be adequate suppression. And so they're still going to be reducing yield loss, adding seeds, or they will still be reducing yield, adding seeds to the soil. So we want to be integrating with other tactics. So if we wanted to be optimizing this, again, we're thinking about weeds that are germinating and emerging through these residue mulch layers. We want to be choosing cover crops that are going to produce more biomass, so we have more residue, and that also have high carbon to nitrogen ratios, so that residue lasts for longer. If we want to optimize that, we want to kill our cover crops as late as possible. We want to keep the residue as intact as possible by maybe using a roller crimper and herbicides. We want to be utilizing our soil residual herbicides as well to help manage resistance. And something we didn't talk about, but that's also important, is just general agronomy. So adjusting our planters so that we have a good crop stand, because our crop is also one of the major tools we have to be out competing weeds. So just in closing for this webinar today, if we want to be optimizing cover crops to suppress weeds, whether it's while they're growing or after they're terminated, it does require some planning. So we need to think about the species that we're going to use. We also need to pay attention to other cover crop agronomy, like the planting and termination date, the planting method, and the seeding rate we're going to use. Cover crops can be really important parts of integrated weed management programs, and they have a lot of benefits for managing herbicide resistance. Even if we're still using herbicides, we're reducing the number of weeds that we have to kill, and we're reducing their size as well, which helps mitigate resistance. And there's a lot of topics we didn't cover today related to cover crops and weed management, including different termination options, how we can reduce the potential for cover crops becoming weeds themselves, and importantly, balancing some of these weed suppression goals with other goals of using cover crops. And there are a lot of resources available through SARE and the regional cover crop councils that might provide you with more information. Thank you for attending this webinar. And if you have any questions, please feel free to contact me at the email provided or the phone number on the screen. And thanks for your attention.